Hi, I'd like to take this opportunity to go over test 2. So here are the questions. There were 13 in all. Here is the first one. State all the factors of 24. This should be straightforward and not require much explanation. 1, 2, 3, 4, 6, 8, 12, and 24. Let's look at question 2. Factorize a polynomial. Now, there are many ways we can factorize polynomials, and you need to know these. I won't list all the methods in this video, but as we do each problem, we'll see which method we apply. So here we start with the simplest approach. We look for the greatest common factor of these terms. And so what's the greatest factor of 15 and 21? Well, 3. The greatest common factor of x squared and x? Well, x. And the greatest common factor of y squared and y is y. So 3xy comes out, and then what goes here then has to be something that when you multiply it by this, you get 15x squared y back. So this has to be 5. 3 5 15. You have to have an x times x squared, and then you don't need a y because we have the y here already. Likewise here, you need a 7. 3 7s 21. We don't need an x because we have an x already, and then y times y will give me y squared. So if you expand this, you get this back. Now for this one, we can see that there's no common factor across, but we can try grouping. So let's do these two first. What's common to 2xy and 14x? Well, 2x. So that leaves us y minus 7. So 2x times y gives me 2xy. 2x times a minus 7 gives me minus 14x. Coming over here, GCF is 4. Leaves me y minus 7 again. 4y, 4 times 7, 28. Now here we notice we have common factor y minus 7 and y minus 7. So this comes out, leaving us 2x plus 4. If you stopped here in the test, I accepted it. However, this can factor more. There's a common factor here, 2. So we take out the 2 and that leaves me x plus 2. So if you got this far, perfect. But I accepted your answer even if you only got this far. In question 4, we're given this polynomial to factorize. Well, we look at it and we can suspect that perhaps this is a perfect square trinomial. So let's look at it. Is the first term a perfect square? Yes. It's 7x squared. 7 7s 49, x squared, x squared. Is the last term a perfect square? Yes. 2 squared. Is this equal to 2 times 7x times 2? Yes, 2 times 7 times 2, that's what? 28x. So that means this is a perfect square, and so we can simply write it as what? 7x plus 2 quantity squared. So let's take a look at this. Remember, for perfect squares, a perfect square is a perfect square trinomial is one that can be expressed as the square of a binomial. So let's take a look at this. This becomes what? A squared plus 2ab plus b squared. So notice, when we have a perfect square, this first term is a perfect square, this last term is a perfect square, and this is 2 times whatever is squared here times whatever is squared here. And so that makes this a perfect square trinomial, and we can simplify it simply as what? The square of a binomial. So what we need to identify is the a. So here the a is like the 7x, and the b is the 2. So it becomes 7x plus 2. Here we are given this difference to factorize. It should be fairly obvious that this is a difference of 2 squares, where the first one is 3x quantity squared and the second one is 5y quantity squared. Check it. 3x quantity squared is 9x squared. This squared is 25y squared. And so that becomes then 3x minus 5y, 3x plus 5y. So we've covered this in class. You know that a squared minus b squared is equal to a minus b, a plus b. And we've derived this in class. So all you needed to do is look and determine, well, what's the a and what's the b. So here the a, that's like this 3x, and the b, well, that's the 5y. See, a squared minus b squared. So then it's a minus b, a plus b. Now for this one, this is a sum of two cubes. Again, it should be obvious that this is a sum of two cubes. The first one is x cubed and the second one is 8y cubed, but 8, you should know that 8 is 2 to the third power. And so to do this, we just need to have memorized this identity, that a plus b cubed is identical, or the equivalent of what? A plus b times a squared minus ab plus b squared. And so here the a is like your x and the b is like your 2y. So it's x plus 2y, and here it's x squared, and then a times b, x times 2y, which is 2xy. There needs to be a minus sign here, and then the last term is like the b squared, and so that's 2y quantity squared, which gives us 4y squared. So the a is like your x and your b is your 2y. So that's a plus b, x plus 2y, a squared, x squared, minus ab minus x times 2y minus 2xy, and then b squared. Remember, 2y squared is 2 squared 4y squared, and that's why we have this here. Okay, so let's look at the next question. Here we're supposed to factorize this polynomial. You look at it and it's not a perfect square. 14 is not the square of any integer. And so we say, well, this looks like just some general run-of-the-mill trinomial. Let's see if we can factorize it. So we multiply 2 times 14, we get 28, and then we find the factors of 28. 1, 2, 4, 7, 14, and 28. And then we see, well, do any of the factors add up to 11 and also multiply to 28? So 4 times 7 gives us 28 and adds up to 11. So that means then we can break up this 11x into 4x plus 7x. And then we just factor by grouping. So what's the GCF of these two? 2x. 2x times x, x squared. 2x times 2, 4x. And the GCF here is 7. 7 times x, x. 7 times 2, 14. Notice common factor x plus 2, x plus 2. We have x plus 2 times 2x plus 7. Now we're given in question 8 this radical expression to simplify. So first thing we do is we express 8 as 2 to the third power, and then we say x to the fourth is x to the third times x, and we say y to the 8 is y to the 6 times y squared. So what are we doing here? We're looking for powers that are the highest multiple of 3 that go into the number that's given to you. So the highest multiple of 3 that goes into 4 is 3. The highest multiple of 3 that goes into 8 is 6. But remember, we can't change what we have. We're just transforming it. So here we have x cubed times x. That's still x to the 4th. Y to the 6 times y squared. That's still y to the 8th power. And of course, then we know that any root, the third root of, let's say, ab is equal to the third root of a times the third root of b. So that's what's going on here. So we take these two products, this one, and find the third root of this, and then we find the third root of this. And of course this simplifies easy now, because what cube gives me 2 cubed? Well, 2. What cube gives me x cubed? That's x. What cube will give me y to the 6? Y squared. Or you can just say, well, 6 divided by 3, 2, 3 divided by 3, 1, 3 divided by 3, 1. And of course then this can't be simplified anymore, and so this remains as the cube root of xy squared. Here we have a very similar problem. So it's the fourth root now, and we have a to the 6. Well, so we need a to the 4th times a squared. We have p to the 15th power, so that's p to the 12th times p cubed, and p to the 9th, so we go with 8 and 1. And then we just apply the same rule that we applied just now. We break this up. And so we have a to the 4th, p12 over m to the 8th, and then 4th root of a squared p cubed over m. And then this simplifies out easily enough. So a 12 divided by 4 is 3, p cubed. In other words, p cubed to the 4th power will give us 12, p to the 12th power. And then of course m squared to the 4th power will give us m to the 8th. 8 divided by 4, 2. And then this remains as is. This can't be simplified anymore. Now for this one, surprisingly some students found this difficult. As this is, we can't simplify it, but you should have recognized that there is a square root of 2 here. So the square root of 18 is really the square root of 9 times the square root of 2. So then we can take out that square root of 9 becomes 3. So then we have 12, so that's 5 square root of 2 plus 12 square root of 2, that gives us 17 square root of 2. Here we are supposed to expand and simplify this expression. So square root of 2 times square root of 3, square root of 2 times square root of 5, and then this becomes square root of 2 times 3, which is 6, square root of 2 times 5, which is 10, and that's it. You can't do anything else with this. And here we're supposed to rationalize this. So remember, the point of rationalizing is to not have any radicals in the denominator. So we cleverly multiply this by root 3 over root 3. This is 1, and so whatever we get has to be the same as what we started out with. Root 3 times root 3 is 3. By the very definition, what is the square root of 3? It's a number that if you multiply it by itself, you get 3. So if I multiply it by itself, I get 3. 5 times the square root of 3. Once again, we're asked to rationalize this expression. And so what we do in this case is we multiply the expression by 1, but in the form of the conjugate of this divided by the conjugate of this. And so what's the conjugate of square root of 3 plus 7? Square root of 3 minus 7. So why are we doing this? Because we know that a plus b times a minus b will give us a squared minus b squared. And if a or b happen to be square roots, then the square root sign will go. So that's what happens here. When we multiply this across, we get 4 times the square root of 3 minus 7, and underneath here we get this squared minus this squared. And so square root of 3 squared is 3, 7 squared is 49. When we subtract that, we get minus 46. If you stopped here in the test, I accepted it, no problem. But this could have been made to look a bit better. Multiply top and bottom by negative 1, this becomes plus 46, and then this becomes plus 7, and it becomes minus square root of 3. And so I think this looks nicer. Okay, so that brings us to the end of this. I hope you found this useful in some way. Thanks for your attention. Bye.